Hello makers! Today on MakerCraft Live we're going to make some LEDs blink. Blinking LEDs on and off is a common introductory task when learning about microcontrollers. We will be performing the same blinky LED example on both an Arduino Nano and a Raspberry Pi 4 to help show that although there are fundamental differences between these microcomputers, they may also be used to produce similar results. We will also walk through the very basics of setting up a Raspberry Pi. We may occasionally venture into topics which are outside of the scope of this tutorial, but we will try to keep things simple. Be sure to visit our Facebook and other social media, and be sure to come into the creation station once we're open again to the public. Here's the stuff you're going to need: a Raspberry Pi. Any addition should work for our task. Here is a 4 inside an acrylic case. You're going to need a micro SD card to put the data on for the Raspberry Pi. I have a 32 gigabyte here, but I recommend anything at least bigger than 16. You're going to need a way to put data on the SD card. Here I have an all-in-one card reader. You're going to need a monitor, which can use HDMI, a keyboard, and optionally a mouse. An adequate power supply for your Raspberry Pi, which you'll need to look up based on what version you have, and an HDMI cable to use with your monitor. Often, if you buy a Raspberry Pi as a part of a kit, many of these things will come with that kit. You're going to need an Arduino. I have an Arduino Nano here, but any should do fine. We will be using the onboard USB to program it and to give power to the Arduino. You're going to need an LED. Here we have a red one. You need a resistor. And you need some jumper cables or wires to connect everything together. I have jumper cables and a breadboard. These come recommended, as they're pretty easy to use. Here we have a setup which shows the very basic principles at hand for our tutorial. We have a breadboard, an LED, a resistor, and some wires to connect things together. This is a very basic LED circuit. Wires provide electricity, and a resistor in series with the LED to regulate the power provided to the LED. Without the resistor, the LED would quickly burn itself out. We can line up the LED with a battery, like so. This is the positive end, and this is the negative end. So the positive to positive, negative to negative, it lights up. However, this is a somewhat inconvenient way of making the blinking light. I would have to disconnect it and connect it the whole time I wanted the battery or the thing to blink. So what we're going to do is we're going to put a switch in line with the battery. Now, when you want it to blink, you can press on this button, and it will blink on and off. This is maybe somewhat less convenient than our other arrangement, but it shows the point that what we will end up doing is using the microcomputer to be this switch. All the microcontroller will be doing is connecting and disconnecting an electrical connection. So let's go set it up. The first thing we're going to do is install the Raspberry Pi operating system. Plug your SD card into your computer however you see fit, and we will go to the Raspberry Pi website, which can be found at raspberrypi.org. We'll navigate to the download section, where we will find this Raspberry Pi imager for Windows, which is what I'm using today. We'll go ahead and download it and run it. Today we're going to install Raspbian, select our SD card, we're going to hit write. Now we're going to switch on the Raspberry Pi, and the first thing we'll see are some test displays. This is the first time that we've turned the Raspberry Pi on with this SD card. This is a screen that is just kind of telling me that it's going to reset. Gotta just wait for a little bit of the initial setup here. It'll boot and reboot, and we just get to hang out. How are you doing? Hope you're doing well. Patience is a virtue. Alright, so here we are on the desktop. And I think I zoom in a little bit here so that we can read what's happening on the screen. This is the initial setup here. Welcome to the Raspberry Pi desktop. Before we start using it, there are a few things to set up. We live in the United States and near Los Angeles, as far as the time zone is concerned. We're going to use a US keyboard and the English language. You should definitely change the default password, but I will not right now, because this is just for show. This is an option for video, and here you connect to your Wi-Fi network. I'm going to type in my password. Connect to the Wi-Fi, and the first thing it will do is ask us if we want to update the Raspberry Pi. If you're just doing this to follow along at home, you could probably get away with hitting skip as I do, but I recommend that you go ahead and update everything, because you might as well. But it's all set up, and it just wants to restart, and then we'll be done. Now that we have the Raspbian operating system installed, we're back on my Windows computer, because it's much easier to record the desktop from here. So today we're going to be using the Raspberry Pi's GPIO to blink the LED on and off. GPIO stands for General Purpose Input and Output, and it is a series of electrical connections which can be controlled using programs on the Raspberry Pi. Here we can see what some of these pins actually are. These red pins and these two yellow pins are just power pins. They're not controllable. They always just provide 3.3 volts or 5 volts. These black pins here are ground pins, which will allow you to complete circuits between high or these powered pins or these controllable pins. And these remaining pins are all programmatically controllable. Today, we will be using Python to control them. You'll notice that these pins have numbers on them. 14, 15, 18. These are the GPIO numbers. However, there are several different ways to refer to the numbers to which pin you're referring to on the Raspberry Pi. There are several different numbers that you can use to refer to each pin. For example, this pin is both pin 8 and GPIO 14. It's important that you might have to tell your program which nomenclature you're using. Are you using the board numbers, or are you using the GPIO numbers? Let's look at which one we're using in our Python program next. So here we have our Python program. This top bit here is a setup that establishes the conditions which our program is going to run in. Here we're going to import the GPIO library. This library is a series of a bunch of code that other people have written that you can use to allow you to save yourself some time. You can call various functions. Here we have a lot of different commands that we can use related to controlling the general purpose input and output on our Raspberry Pi. And this second thing we're going to do is we're going to import the sleep function from the time library, and this allows us to wait. It allows us to pause in our program. On this next bit, we are setting up the GPIO pins. Here we're kind of just doing some housekeeping, and we're telling the program to ignore errors. This is just to keep our heads straight. Here we're going to be telling the program that we're using the board layout for the pins, the board numbering, which is this set right here. So that means that we're going to be using pin number 8. And here we're telling the program, we're basically roping pin number 8 into our program, or telling it that we're going to be controlling it with this. We're using GPIO setup to say pin 8, you are an output, or you will be turning on or off, versus sitting there and listening for other things, turning that wire on or off. And initially, we're going to be off or low. This is the chunk of the program that actually kind of does stuff. Here we have a while loop. So while the next thing is true, do this stuff. As long as this next part is true, then do all of this. However, we have true written here. True is always true, so it's going to run forever, or until we stop the program. So here we say GPIO output, turn pin 8 to high, or turn pin 8 on, and then wait for 1 second. Then GPIO output, we're going to tell pin 8 to go low, or turn off, and then wait for 1 second. And it's going to do this forever, or until we turn off the program. So let's go see this program on the screen of our Raspberry Pi and see if the light will blink. So here we're going to plug in these cables. 1, 2, 3. This is the ground pin. It's going to go to the negative side of the LED. Right there. And this is the positive side. We're going to plug it into that pin 8 from right before. And it's going to go to the positive side. There's the program up on the screen. It's the same program as we just saw. I'm going to kind of stare at it for a minute, and then we have to save it before we run it. We'll save it as pytest.py. .py is the file type for Python programs, and then we're going to hit run. it's blinking. Pretty cool. Now that we've made the LED blink with the Raspberry Pi, let's make it blink with the Arduino. We'll go to the internet and navigate to arduino.cc, which is the Arduino website, where we can find, under the downloads or software and downloads page, the Arduino IDE. An IDE is a set of software which makes it easy to program. Here in this case, it makes it especially easy to upload programs to the board. So let's go ahead and install this. So now that it's installed, let's launch the program. It just so happens that the thing that we're trying to do on the Arduino is one of their example sketches. A sketch is Arduino talk for a program. Let's take a moment to highlight one of the key differences between a Raspberry Pi and Arduino. They both have GPIO, sort of. But an Arduino is more or less just a GPIO, and enough brains to sit here and run one program, or sketch, over and over and over and over and over and over again. Here we have the first chunk, which again, sort of establishes the things that the Arduino needs to know in order to act. And this second chunk is called the loop, and the Arduino will just do whatever is in the loop for as long as it has electricity to it, forever. The Raspberry Pi is really more meant to be interactable. It will sit and wait for you. It has a desktop. You can connect a mouse and a keyboard to it, and a monitor, and look at what it's doing, and communicate with it and talk to it. But it also has a GPIO, and you can also run programs with it that will do similar things. The Raspberry Pi, as well, is more of like a traditional computer where you might have a lot of ways to move files in and out of it, or to change what it's doing at any given time. With your Arduino, if you want to make a change to what it's doing, you have to unplug it from wherever it is, plug it back into your computer, and upload a new sketch to it. This is just one of the differences between them. So although the blink is an example sketch that the Arduino manufacturers provide for us to sort of understand their device, we need to make a few changes to it in order to get it to work with what we are doing specifically. The Arduino has a built-in LED, and the blink sketch by default uses the LED that's built in on top of the Arduino itself. But here we're going to tell it to not do that. We're going to use the separate LED that we used for our Raspberry Pi. So now let's walk through our Arduino program and kind of see what it does. Here, like I mentioned, we have this setup. This is sort of establishing what the Arduino is going, the sort of information that it needs in order to do what we want it to do. Here, we're creating a variable so that we don't have to use this number 6 over and over and over again. We can just refer to our pin. This is handy if you end up changing which pin you're using. For here, it's just for readability. So we're going to, very much like the Python program, this here establishes, it sort of ropes this pin into our program. Here, We're going to tell it pin 6, or our pin, and we're going to declare it to be an output. Now we're going to go over to the loop. This subsection will just happen over and over again. And unlike with the Python program, we don't have to tell it conditions for it to do this. We could, but the loop chunk of an Arduino sketch will just repeat anyway, so we don't have to. Digital write is the Arduino talk. This is the function, which basically tells a pin what to do. Here we're telling our pin, pin 6, to go high, or turn on. And then we wait 1 second. Delay is the Arduino talk for waiting. And 1000 here refers to 1000 milliseconds, or 1 second. Digital write again. Our pin, low. We're turning the LED off. Oh, wait a second. And this will loop over and over and over and over and over again. So now we're going to tell the Arduino IDE what kind of board we have. This is sort of important for programming it accurately. We have an Arduino Nano. So we'll go to Tools again. Now the board says Arduino Nano. And we'll kind of look at what's going on here. Processor. Sometimes you might need to select a different processor. Usually when you buy your Arduino, a lot of this information will be wherever you bought it from. In particular, if you buy Arduinos from Amazon, there will often be a comment or a question or a review that has this information in it. It's the unfortunate nature of the hobby that is the way it is, but it's also blessed that people should be so helpful. Port here is an important one. Usually, when you plug your Arduino in, a new port will appear here, and that's your best bet for knowing which one of these is the thing that you need to select. But you absolutely need to make sure to select one of these. COM1 is almost always connected on my computer, so COM3 is going to be the one that the Arduino is on. Alright, that's kind of all you need to do for that setup. So now, I'm going to drag this up. This is the output for a lot of what the IDE will do next. So next we're going to hit upload up at the top here. So I got the program to work. I had to leave in order to fix it. Just to show some simple programming goofs. I'm a baby at this, but our pin, I had not declared what kind of variable our pin was. So here I've told it it's an integer, so that's a number. Here we have an integer, right? And that basically fixed it up. I also forgot to put these semicolons that end that line. Programming is really outside of the scope of this particular tutorial, but I thought I would share. So now we can go ahead and hit upload. And it should compile just fine, and it will upload. Whoop. Alright, I'm back again, and just to show off that particular goof, not really sure why this fixed it, but I went to processor and I switched it to old bootloader. Sometimes there are so many different Arduinos made by so many different third-party manufacturers all over the world at different times. Sometimes you need to fuss with it. But here it says done uploading, and I can do this again. We'll go ahead and hit upload. And it's done uploading. And we should begin.